Okay, implicit differentiation, all the differentiations we've done so far have been one variable contained, right? So you had like x, or you had t, or you had m, and all the rest of the variables then were just were just numbers, like a or b or c. If they were contained with an x, were just numbers. Implicit differentiation, we're going to actually differentiate y's and x's. Now this happens in when you get like hyperbolas, or when you get circles and stuff like that, and you have x squares and y squares embedded in the equation. So an example of this would be if, pardon, example 1, I don't know why I have an 11. That's fantastic. Example 1, if x squared plus y squared equals 25, find dy dx. Now, often instead of dy dx, I used y primes because it's the same thing. But when you do implicit, it's better to use dy dx or dx dx because it's with respect to x. And you'll have some later on with respect to t or with other things. So it's better when you actually use the Leibniz notation for these. So, and it'll explain why when you have an x, you don't have the dx's with. So if we take the derivative of x squared, you drop the 2 in front, you get 2x, drop it by 1. And if you're using Leibniz notation with respect to x, everything is with respect to x, we'd have dx over dx. And dx over dx is just 1. So that's why you don't have to write the derivative for the x. That's why you don't get a variable derivative behind it, because it's all with respect to x. So dx over dx is just 1. Then we do the derivative of y squared. So 2y. Then it's dy over dx, because they're always over dx. That doesn't cancel. It doesn't go away. It's not dx over dx. So that's why that one stays, and the x one you don't have to have. Often what we just say when you have y, put a y prime behind it, because when you take the derivative of y, you have to have it. But then no one understands why you actually don't have to do it to the x. And with Leibniz notation, it's a little bit more understandable why the x doesn't have one, because they actually cancel. It does have one, but it goes away. Just like ln e. It has ln e, but it goes away because it's 1. So it still follows the same rules. Then everyone writes 25 behind. Don't be that person. What's the derivative of 25? 0. Huge common error. I do it all the time by accident, because I write the 25 behind instead of taking the derivative of it, which is 0. Now our full goal is to just, we have to always solve for dy dx, because what we're trying to find is the derivative of y. Dy dx is just Leibniz notation for the derivative of y. So we need to get it by itself. So the first thing I'm going to do is subtract the 2x over. Then I'm left with 2y times dy over dx equals negative 2x. And then I need dy dx by itself, and it's multiplied by 2y, so I'm going to divide by 2y. So dy dx equals negative x over y. You could say y prime equals dy dx equals negative x. It's the same thing, right? One's just different function of way of writing it. So this, technically, negative x over y is the first derivative of x squared plus y squared equals 25. B. Find y prime if x cubed plus y cubed equals 6xy. This one's harder, because on the right-hand side of the equal sign, you have product rule. A lot of people forget to do product rule on here. They'll just say 6y prime or something crazy behind it. It's product rule. It's two variables multiplied together. So 3x squared times dx over dx technically. Plus 3y squared dy over dx. Whenever you take the derivative of a variable, you're always writing it with respect to x unless it's specified with respect to time or something like that, which we'll be doing later when we do word problems. And then it equals, so f equals 6x, g equals y, f prime equals 6, g prime equals, derivative of y is 1. This would actually be 6 dx over dx, technically. So that goes away, so it's just 6. This would be 1 dy over dx, or just dy over dx. So when we do product rule, we get, it can be fg prime plus gf prime, right? But we like doing gf prime plus fg prime just because it's closer to the quotient rule. So g, dy over dx, g, not g prime, geez Louise, g, which is y, f prime, which is 6, plus f, which is 6x, times g prime, which is dy over dx. Do you remember when you solved for exponential back in the day when it was like in 30-1, when it was like 2 to the 3x plus 1 equals 3 to the 4x plus 1, and you'd log both sides and you'd distribute the x's in front, and then you'd move everything to this side that didn't have an x and everything to this side that did have an x so you could pull the x's out? And you're like, no, that was a few months ago. I don't remember that. Anyways, that's the same thing we're going to do here. We need to get dy dx by itself, right? So what we're going to do once you've actually taken the derivative of everything is anything that has a dy dx, you move to one side, and any term that doesn't have a dy dx, you move to the other side. So I'm going to keep 3y squared dy dx over here. And then I'm going to subtract 6x dy dx over to this side. And then I'm going to keep 6y over here, and I'm going to subtract 3x squared. Why would I do that? Why do I get all the dy dx terms to one side and everything else to the other? What could I do now? I know you guys know the answer. What could I take out of the two terms? Yeah. dy over dx. Now I can GCF out a dy over dx. So I have dy over dx, 3y squared minus 6x equals 6y minus 3x squared. And then I just divide that over to get dy dx by itself. So now y prime or dy dx equals, and I can take a 3 out of each of these. So 2y minus x over y squared minus 2x. Right? Just reducing it. Now, what happens if I would have, what's up? Yep, good call. X squared. Now, what would happen if I had chose to move the dy dx's to the right side and everything else to the left side? You'd get the exact same answer, opposite signs. So you would get negative 2y plus x squared minus y squared plus 2x. It's the exact same answer. Why is that the exact same answer? Because if I times this by negative 1 on the top and this by negative 1 on the bottom, am I changing it? I'm not changing my answer. I'm changing the look of my answer, but my answer would be the exact same as long as I did the same to the top and the bottom. So if you get an answer and in your homework and it's the complete opposite signs of the textbook, you're right. Because you could just take a negative 1 out of the top and the bottom and they would cancel off and you'd match the textbook. It just means the textbook answers moved it to one side and you moved it to the other side. That's all. So as long as your answer, so if you would have gotten negative 2y plus x squared minus y squared plus 2x, you would be still right. Because you could pull a negative 1 out of the top and the bottom, technically, and it would change all the signs and you'd match the textbook. Okay? But every single sign has to be different. If 3 out of 4 are different, you made a mistake. Go back, try again. Okay? Example 2. Same question. We'll just find the tangent. So find the tangent to x cubed plus y cubed equals 6xy at the point 3, 3. Whenever we want an equation of a tangent, we always have to find the first derivative to get our tangent slope, right? It's our very first goal. On the previous page, we already got it. We already got our y prime, which is our m tangent, slope of our tangent, because it's the exact same question. X cubed plus y cubed equals 6xy. What was the answer? I don't remember. On the previous page. Help me. Steph? What was on the bottom? So that's my tangent slope if I didn't have a point, right? If I just asked you for the equation of a tangent slope and I didn't give you a point, you'd be done. But I did give you a point. Normally for our tangent slope, we just fill in our x and get our tangent slope, correct? But actually for this one, we'd have to fill in our y as well. Remember, I also told you that this is a gift, me giving you the x and the y. That's a gift to you, because I could just give you the x and make you solve for the y. Or I could just give you the y and make you solve for the x by plugging it back into the original, right? I only need to give you the x or y to get an equation of a tangent. If I give you both, that's a gift, because I'm not making you do an extra step, all right? So if I want the slope of the tangent, I have to actually fill in my x's and my y's for this one, because I have both, and get the answer. So I'm going to get 2 times 3 minus 3 squared over 3 squared minus 2 times 3. So I get 6 minus 9 over 9 minus 6. So on the top I get negative 3. On the bottom I get positive 3. So my tangent slope is actually negative 1. Okay? Then you do the exact same steps as you would have done before. Y equals mx plus b. I have my tangent slope. I have my point. Plug them in. Solve for b. 3 equals negative 1 times 3 plus b. Add 3 to both sides. 6 equals b. So my equation of my tangent is y equals negative 1 x plus 6. All right, so not too bad. Yeah, because we're getting a tangent line. It's always a line, not a parabola or any other type of shape. Yeah. All right, we'll do one more of these, and then for tomorrow we'll save implicit differentiation on trig for tomorrow. Yeah, you get trig too. Okay. Example 3. Find y double prime if x4 plus y4 equals 16. So when we do first derivatives of everything, we find our first derivative. If we need our second derivative, we need our first derivative to find the derivative of. If I wanted you to find the 50th derivative, you'd need the 49th to find the 50th, unless in hopes that you maybe see some sort of pattern or it ends up becoming 0 after you take enough derivatives. Like polynomials would become 0 after a while because x to the 4 become 4x cubed, would become 12x squared, would become 24x, would become 24, would become 0, 0, 0, 0, 0, right? So eventually those ones would go away. But quotient ones just keep going and going and going. So you need the previous ones. So that's fine. This one, you for sure need the previous one, and I'll show you why. Okay? So we do our first derivative just like we did before. 4x cubed, technically dx over dx. Gone. Plus 4y cubed, dy over dx, equals 0. Now, if you guys want, you can go 4x cubed plus 4y cubed y prime equals 0. You can do that as well and just solve for y prime. A lot of people like that better because it's not the fractions. But I always start off with a dy over dx just so you see why the x goes away and why the y doesn't. And then when we use t, y, x, and y both don't go away. Because if you have dx over dt and dy over dt, nothing's going away, right? Nothing cancels. So with respect to time, they would stay, which is in our related rates. So we're going to move the 4x cubed over. And you have 4y cubed y prime equals negative 4x cubed. Divide by your 4y cubed. And y equals negative x cubed, y prime, sorry, equals negative x cubed over y cubed. For implicit differentiation, when you go to do the second derivative of the first derivative, you will need the first derivative as well after you even start, which will make sense in a second. So, if we want the second derivative, we need to find the derivative of the first derivative. You can do this two ways. You can treat it like quotient rule, or you can treat it like product rule with y to the negative 3. Correct? Either way would work. If you use quotient rule, often you're not moving stuff to the bottom at the end because it already is in the bottom. If you use product rule, you're going to have to move your negative exponents down. So, which one's better? I don't really know. Okay. So, let's do product rule. So y prime equals negative x cubed times y to the negative 3. I just brought the y up, made it negative. This is f. This is g. F prime is negative 3x squared. Technically dx over dx, so that's why we don't write it. G prime is negative 3y to the negative 4 y prime. And if I take the derivative of y prime, what do I get? Y double prime, technically, yeah? So the derivative of y prime is y double prime. And then I do product rule. Wait a second. How can I solve for y prime when I have a y double prime? I'm not solving for y prime. I'm solving for y double prime. Okay? However, I know y prime. What is y prime? Negative x cubed over y cubed. Plug it in. It goes away. And I'm just solving for y. This is the step where people forget. They like sit there or the blank, or they fill it in with the y prime and then just cry a little, and then I get a question without it answered fully. You have to remember that you know y prime. You just solved it. Plug it in. Okay? So we're going to plug it in before we even do the derivative. It'll be gone. So g prime then would be negative 3 y to the negative 4 times y prime being negative x cubed over y cubed. Let's reduce that. So we're going to get negative 3 times a negative x, so positive 3, x cubed. And what's y to the negative 4 over y to the 3? Y to the negative 7. Then we do product rule. Okay? Some people fill it in with the y prime into their product rule with just the y prime in it. And then at the end, when they go to simplify, then they simplify it. I like doing it right then and there, and then it's gone and we don't have it anymore. Okay, so remember you could do f times g prime plus g times f prime, or g times f prime plus f times g prime. It doesn't matter which way you do it because it's product rule. Only quotient rule really matters. So g, y to the negative 3 times f prime, which is negative 3x squared, plus f, negative x cubed, times g prime, which is 3x cubed y to the negative 7. So we technically get negative 3x squared over y cubed minus 3. X cubed and x cubed is x6 over y7 then. Could we put these together? Absolutely. We could, with getting a common denominator if we wanted to. I'll show you that, just one more step, just if we wanted to do common denominator. When you have monomials on the bottom, it's easier because you can just make this one be y7. If I times this by y4 over y4, it is y7, right? When you have monomials, one term on the bottom. So you could get on the top negative 3 times this by y4, y4. So you get negative 3x squared y4 over y7 minus 3x6 over y7. So technically you'd have y double prime equals negative 3x squared y4 minus 3x6 over y7. If you wanted to go further, you could take out a negative 3x squared and you'd be left with y to the 4 minus x to the 4. So it's totally dependent on your answer, or if they want it reduced fully to common denominator. We still have to do implicit with trig. We'll do that tomorrow. And then we still have logarithmic differentiation, logs and lns, and then rate of change, which is word problems with it. Unit test will be when you come back. I'm going to give you guys an assignment instead. Good call. Yeah. It would be plus. So your homework is page 215, number 5 to 9 odd. 15. $27. $35, $37. That's good for now.